Let me know if I'm audible.
Yes, ma'am, you are audible.
Okay, thank you. The next question that you have is 10th. The 9th question is deleted. Question number 10th, if circles are drawn taking two sides of a triangle as diameters, prove that the point of intersection of these circles lies on the third side. Do compare this question with example number 5. These are almost similar. So what you have to do is you have to take a triangle and then you have to draw circles with any two sides as diameters. So let's say we have triangle ABC and draw two circles. एक बार आपको circle draw करना है with AB as diameter. So there will be a circle right around here, and then there will be a circle with any other side out of the remaining two as diameter. So I'm drawing a circle with AC as diameter. So what you need to prove is when these two circles intersect, the point of intersection would lie on the third side. So right now in this figure, you can like see, if even if you do it by drawing, अगर आप draw करके भी करते हो, you take any two sides as diameter and then you construct two circles, then you will see that the point of intersection of those circles falls on the third side of the triangle. You have to prove that theoretically without doing any construction. So you can draw the figure like such that we have two circles, one with AB as diameter and the other one as AC and diameter. While drawing your point of intersection, in this case, let's say it's D, may or may not appear on the third side. But what you can do is you can prove later that D will be on BC. Means agar hum is tarah se banaye, like deliberately if I draw, let us say there is a circle with this side, AB as diameter, and then there is another one with AC as diameter, and the point of intersection is outside. So right now what I've done is I've taken the point of intersection outside, just a little below the side BC. But eventually what we'll prove is that BDC, if I join these 3 points, point B with B, B with C, these 3 points will be collinear. That would mean BDC is a straight line. That is only possible when D is lying on the line segment BC. This is what you want to prove here. To prove that D lies on BC, you want to prove that BDC are collinear points. And I guess that's what the example is. Example number 5, you prove that the point of intersection lies on that side, which joins the two ends of the diameters. So the question is similar. So what you will be doing is you will be taking the two the two circles one by one, considering their diameters. We want to draw the common chord first of all. Let's draw the figure. So question number 9th again is deleted. Question number 10th, I have taken a triangle ABC. I've drawn circles with AB and AC as diameters. The point of intersection is D. I have written here. Circles intersect at D. The circles are drawn with diameters AB and AC respectively. You have to prove that D lies on BC. You will prove that BDC, these points are collinear. And to prove that, you need to prove that BDC or BC is a straight line. And I shall be proving angle BDC as 180 degrees. This would mean BDC is a straight line. That would mean BDC are collinear. I'm going to construct the common chord, draw the common chord for the two circles. And if you remember from, I think, second exercise, the common chord is drawn by joining the points of intersection. So you will draw the line segment AD, and that will be the common chord. Now, keeping in mind what we want to prove angle BDC is 180 degrees. What I'm going to do here is I will prove the sum of angle 1 and angle number 2. Angle 1 and angle 2 together form angle BDC. I'm going to prove that angle number 1 plus angle number 2 is equal to 180 degrees. And for that, I will consider the two semicircles that I obtained because of those diameters. Just consider this. If I just Ignore the second circle. Looking at this circle right here, AB is the diameter. If AB is the diameter, angle number 1 is angle in semicircle. Its measure will be equal to 90 degrees. Similarly, if I go to the second circle and I ignore the first one, and if I ignore the first circle, looking at the second circle, AP is the diameter. And if AC is the diameter, angle 2 will be the angle in the semicircle and its measure will also be 90 degrees. So what you get is each of these angles is equal to 90 degrees. Together their sum will be equal to 180 degrees, which makes angle BDC equals to 180 degrees. So I'm going to go back to the original figure here. If you want, you can write this down that AB is diameter and AC is diameter. Angle number 1 will be equal to 90 degree and angle number 2 will be equal to 90 degree. These are angles formed in the semicircles. And if you consider angle BDC, it is angle 1 plus angle number 2. If you don't want to write down the numbers, you can name these angles. This will be angle BDA plus angle CDA. The measures of each of these is 90, which makes angle BDC a straight angle. Angle 1 and angle 2 actually are touching the circumferences. Just observe. Let's see. Now you can see angle number 1. Angle number 1 is formed on the circumference and it is subtended by the endpoints of the diameter. The diameter is forming angle BDA, angle number 1. This one. And similarly, you can look at the other one. Anyone with questions here? Example number 5 is just like this one. You are using the same properties that you will have two angles formed in semicircles. The measure of each of those will be equal to 90, which makes that whole angle BDC a straight angle, and hence you can prove that BDC lie on the same straight line. That is what we wanted to prove here. If anyone's writing down, please let me know.
Ma'am, wait.
Okay.
Ma'am, done.
Question number 11th. You have two triangles, two right triangles with common hypotenuse AC. Prove that angle CAD equals to angle CBD. So you want to draw a line segment AC, or you can draw two triangles which have AC as the common hypotenuse. So simply if I had to draw, let us say this is triangle ABC. AC is the common hypotenuse. The right angle will be at B, obviously, because AC is the hypotenuse. The angle opposite to AC will be 90 degrees. Similarly, there is another triangle for which AC is the hypotenuse. So I'm going to draw that on the other side. So this is the second triangle that you have with AC as the hypotenuse. The name of this triangle is ADC. So you have one triangle with AC as hypotenuse on either side, and then there is another triangle on this side for which AC again acts as the, sorry, I said AC as diameter, AC is the hypotenuse. And in the second triangle, the right angle will be the angle opposite to side AC. You have to prove that in this figure formed, angle CAD equals to angle CBD. Although you cannot see one of these angles, you can see CAD, you cannot see CBD. So for that, you will need to join BD. अगर हम BD को join कर दें. The figure will get complicated step by step. Just observe, you have two triangles. Going back, we have two triangles for which AC is the hypotenuse. एक right triangle बनेगा below AC, एक right triangle बनेगा above AC. You could also draw AC horizontally and then draw two right triangles, one on top and one below. The angles opposite to AC will be 90 degrees because AC is the hypotenuse. After that, in this figure, the quadrilateral so formed, you want to prove angle CAD. Angle CAD is this one, angle number 1, and angle CBD are equal. So CBD will be this one. Observe, CBD is not 90 degrees, CBA is 90 degrees. CBD is a part of CBA. You want to prove angle number 1 equals to angle number 2. What we shall prove is that the quadrilateral formed here, ABCD, is a cyclic quadrilateral, which I guess is clear by now because जो हमारे पास figure बन रही है उसमें opposite angles का sum 180 बन रहा है. जब भी आपके पास quadrilateral बने जिसके opposite angles का sum 180 हो, उस quadrilateral को हम cyclic quadrilateral बोल सकते हैं. और साइक्लिक क्वाड्रिलेटरल का मतलब ये होगा कि जो चार वर्टिसेस हैं आपके पास क्वाड्रिलेटरल के, उन चारों वर्टिसेस में से पास होने वाला सर्कल ड्रॉ किया जा सकता है. Are you clear till this point? Like anyone with questions still here what I just said? हमारे पास क्वाड्रिलेटरल बन रहा है and on observing इस क्वाड्रिलेटरल का एक pair of opposite angles is supplementary, angle B and D. So if you just observe from here, you can see we have two triangles, right triangles with AC as the hypotenuse. B is 90 degrees and D is 90 degrees. ये जो quadrilateral आपके पास बना A, B, C, D, इसका एक pair जो है opposite angles का, it is supplementary. B and D, they are supplementary. If one pair, any one pair of opposite angles of a quadrilateral is supplementary, we can say ABCD is cyclic. So that is the first thing you want to prove. ABCD is cyclic. That will be step 1. Don't write down. This is just, I'm just going over roughly here. So once you've proved ABCD is cyclic, that simply means कि ये जो points हैं आपके पास A, B, C, D, इन चारों points में से pass होने वाला circle draw किया जा सकता है. And I have done that here. So if you can observe, this is the same figure. Triangle ABC, B पे 90 degree angle बन रहा था. ट्राइंगल एडीसी डी पे 90 डिग्री एंगल बन रहा था. बिकॉज ये क्वाड्रिलेटरल साइक्लिक है तो हम इन चारों वर्टिसेस में से पास होने वाला सर्कल ड्रॉ कर सकते हैं. एंड वंस यू कैन ड्रॉ दिस सर्कल, now you can apply the properties you have studied about circles till now. Keeping in mind what we want to prove, we wanted to prove angle CAD, angle number 1, equals to angle CBD, this angle. Which property do you think will be applicable here?
Chord subtends equal
Angle
angles at the
subtend chord
circumference.
That's correct, Dakshan Saloni, that's correct. This angle 1 and angle number 2 is subtended by CD. CD is the chord or the arc which is making angle 1 and angle 2. Observe closely. दोनों एंगल्स जो हैं वो कौन सी कॉर्ड सबटेंड कर रही है? The same chord, CD. CD is subtending angle number 1 at point A and angle number 2 at point number B. The result that you'll use here is angles in the same segment. Or you can say that's angles subtended by the same chord on the major segment. They will be equal. बट ये रिजल्ट सिर्फ तब अप्लाई होगा अगर आपके पास सर्कल बन रहा हो, सर्कल की कॉर्ड हो जो सेम सेगमेंट में डिफरेंट एंगल्स सबटेंड कर रही है, तो आप उन एंगल्स को इक्वल प्रूफ बोल सकते हो. बट टू apply that result, the first thing you want to prove is that you have a circle formed here. The circle will be formed if this quadrilateral is cyclic. So that's what we are going to do. Let's write down and then you can just go over the proof once again and see if you follow. Draw the figure to prove angle CAD is equal to angle CBD. I have not drawn CBD. We are considering the sum of the opposite angles. Angle B, it's 90 degrees. Angle D is 90 degrees. The sum comes out to be 180 degrees. You can draw the circle right there in the figure that you have drawn in the beginning, or you can draw a figure separately if that is okay with you. You can just change the one you've already drawn. So you can just draw a circle, draw it roughly. There's no need to draw it properly. So draw a circle roughly, passing through the points A, B, C. That's all with your proof. You can write down angle CAD equals to angle CBD. Anyone with questions? All right. This completes your exercise and the chapter. After this, we have to do constructions, but just go over the assignment. In case there is any doubt, do let me know, share it in the group. I'll try if we can discuss that tomorrow or maybe a day after tomorrow, maybe, or we shall start with constructions. Please keep your geometry boxes with you tomorrow.
Okay, ma'am.
If there is any other question you want to discuss, do let me know. That will be all. If you're writing down, let me know, or else I'll just end the meeting. And we'll see you tomorrow. Anyone who's writing down?
No, ma'am.
All right. God bless you all. I'll see you tomorrow.